can't beat the in-person interactions, the lunches, the dinners. The quality of the people that you meet over coffee here is just phenomenal.
Welcome to the first panel of CppCon. And I think it's the most important panel, of course, but that's just me. It's about safety, it's about security, it's about what we as a committee have done in the last year for C++ safety and security. And there has been a lot, really. When I introduce the panelists, they will talk about the things they've done. And some of them have done multiple things on multiple items. So tell them all what it is that you've done. And we will base those questions on what they've done. This is kind of a panel. This is the second year we run this panel. Last year, it was very interesting for everyone to see. But I felt that this year, I really want to dive deeper into the technical details. And if you've seen some of the work, I want to make sure that you have a chance to ask the kind of questions that you really want to know, okay? The kind of question I would want to ask of these guys. So let's get to it. So introduction, my name is Michael Wong. I am a DE and a VP at Codeplay/Intel. Even though I've worked on some of the stuff that they have, I'm nowhere near that level of expertise, but I have a large background in programming model safety and functional safety and MISRA and the C++ core guidelines and profiles. So that's me. Let's start from left to right, starting with Andreas. Okay, please introduce yourself and tell us a little bit about what kind of things you've done.
Yeah, is this on? Yeah, I think
it is.
So. Yeah, hello. My name is Andreas Weis. You may remember me from this panel last year. My background is software in automotive contexts, functional safety there also, and I'm also a member of the MISRA C++ working group.
Gabriel.
Oh wait, before you do, what did you work on last year?
So last year we shipped the new MISRA C++ standard, actually. So that was almost complete at the last CppCon, and we finalized that and we shipped it. It's public now.
Yeah.
And we actually started working on the new revision. Like Yumi, we worked on the parallel guidelines for MISRA C++.
And not just MISRA, but also for
core guidelines, yes. But,
yes.
Now in the last year in particular, we completed the first wording review for those guidelines for MISRA.
Yes.
And we actually started just a couple of weeks ago the initial work on the new MISRA guidelines for C++ 20.
Okay. Thank you. Now we can go on. Sorry to interrupt.
Good. Gabriel, this Reis. I work at Microsoft on anything C++, particular the toolset. We focus on large systems programming, safety and security, and helping the company provide guidelines for C++ developers that are on its platform. I represent the French national body on WG21. I have been working for a while now, almost 10 years now, on the C++ core guidelines with Herb and Bjarne Strostrup. And of course, there the focus is still on safety, how to write good C++. In terms of evolving the language, I have been focused on this cycle around on what's called C++ profiles, and also on contract. And most of that work is inspired by real problems that, see at scale. If you've been using any of Microsoft product that use C++, you probably understand the importance of why that's really impactful.
Okay, so just to make sure, you may not, so MISRA and C++ core guidelines, profiles, contracts, and C++ core guidelines. Okay, just remember these as we go along. Please, go ahead.
So I'm Lippincott. some of you may have come to my talks. I spend a lot of time thinking about program correctness, but over the past year, I've been really focusing a lot on whipping the contracts proposal into shape and getting people on board with it so that we can actually have something from it in C++26, fingers crossed.
Thank you. So I watch you at contracts, and you're kind of like the senior overall advisor. I find that you give good advice about what correctness really means. So I think that's a really important role. So correctness, program correctness, and contracts. All right. Thank you. Herb, please.
The keywords, if we're doing keywords, Microsoft, C++ core guidelines. I wrote a safety essay on my blog earlier in the year about C++ safety in context, saying, yeah, here's the job we need to do, but let's not forget all the other safeties. It's not more than about memory safety, but yeah, that's our job, so let's do that job. But we have to harden all of our software. And I'm very interested in profiles. So I have a paper coming, which is pending publication, on being very specific on what rules go in profiles and how we can make them adoptable and impactful. The core guidelines, interestingly, so there's actually, in a way, two sets of core guidelines that we're talking about here. There's the whole thing, which is, I don't know, hundreds and hundreds of rules. And of varying toolability and such, and in lots of different areas. But right at the end, there's a section of like 24 rules about type and memory safety. Yes. That is the key. Those are the well-known rules that are basically like 80% of profiles, in my opinion. We already know what the rules are, most of them. There's a bit of addition we need to do. I have not mentioned contracts because I may be a contrarian here. We'll see if we get to this. I might get pilloried because I think contracts are very important. I am eager to see them come into C++ and see how well they work. I've implemented them myself in CPP front, including extensions that go well beyond what's being proposed for C++26, including violation handlers and everything. However, they aren't about programming language safety.
I'm going to ask that question very fast.
Provide guarantees. They're good. I'm not against them at all. I love them.
So,
but I have something to say if somebody wants to ask.
Yeah,
and I may get pilloried for it because I may be the only one on stage who says
you and I both, because that is going to be one of the big questions I think people will want to know. What does contracts have to do with safety? But let's not jump into it.
No, I was just going to say a shot has been fired.
I like controversial evenings. They make life more interesting. So let's bank that, exactly. But just to emphasize, Herb's been involved with, the blog post that he wrote in March, which you can easily find, about what it takes for C++ to become safe. We're going to focus quite a bit of questions on that. You talked about the integration with profiles. And of course, I've always known that you worked on CPP2. And what I did not know was how much it was leaning into safety and security. I knew that. I found that out this morning. And you and I have been working together for a long, long time. So that's what it takes. Next, please, Timur.
Hi, my name is Timur Doumler. I'm the co-chair of SG21, which is the contracts study group on the committee. So I've been involved in actually producing the contracts proposal, making sure it's specified right, and helping people agree on certain aspects of it that we didn't necessarily agree on initially. But I think we're kind of converging on a proposal that hopefully might get into C++26. We still have a handful of things to iron out, or questions that we're not quite sure yet what to do there, but we're getting there. I think there's still enough time to agree on those. And regarding what you just said, Herb, I'm actually not disagreeing with you. If you're looking for like language level guarantees for memory safety, that's not really what contracts are about, in my opinion. So no disagreement there, but there's of course nuances there. So we can
Damn, I was hoping to get a fight out of this.
Of course, contracts do help make your code safer. But let's talk about that when we get.
Let's get to it when we get it. But I just want to summarize. Timur's been very capably handling SG21, which is now a big group that's meeting every week virtually, and about 5 to 6 to 7 hours when we go face to face, because you have to go through all the groups to get more, increasing wider approvals. So thank you very much. Thank you very much.
There's two of us as well. So there's also
I know there are
John
two of
Spicer,
you, yeah. So there's John Spicer, who also who leads the group as well too. So thank you to him. All right, so this is how the audience participation comes. There's one mic, just one over there. So if you have questions, please line up over there. And that's why I'm sitting here and I can see that you're lined up, okay? This is your chance to ask, find out, synthesize, analyze what safety in C++ means. And the other thing that I want to say is that what you're getting here is a multifaceted view. I think we all agree that safety is not just one thing, or, we're not bashing contracts as not being, that's just one way. There's profiles, that's another way. There's core guidelines, that's another way. Okay, I probably missed a few other ones already, but the thing is that C++ isn't going to do it isn't going to put all of its money out in one place for what we're trying to do. Okay. All right. So let's start lining up. But before, as you guys prepare with the questions that you have, I'm gonna start right away with that first question, which is, it's actually the same question but flipped two ways, which is, how is ISO C++ contract for safety and security, and how is ISO C++ contracts not enough for safety and security? Anyone, please?
Going the other way now, or? Mm-hmm. Okay. I can say something. So the first thing I'll say is, if you ask 5 people on the committee, like what contracts are for or what they're doing, you're going to hear 6 different opinions. So everything I say is kind of my personal interpretation,
of course,
and not like the opinion of everybody in SG21 or anything like that. So the question is, what do contracts do for safety and what do they not do? Or?
Yeah, how is it not enough?
Right. So come to my talk on Wednesday, but so I think contracts, in my opinion, are actually more about correctness than they are about safety. Mm-hmm. So of course, if you get correctness, you get safety in lots of cases as well. But I would say correctness is like the primary kind of focus. I think what contracts do is they let you add checks to your code that might prevent bugs, they might prevent undefined behavior. Classical example is operate a square bracket. You can add a bounce check on it and turn that on, and that's instantly, possibly, big safety issues gone. I don't know how many % of vulnerabilities are due to out of bounds issues, but I guess quite a lot. That's the number one. So stick contract check on your operate a square bracket and turn that on, and that's gone. If you're talking about a library class, if you're not talking about like language level arrays. But what they don't do is they don't change the semantics of the language, right? So they let you add checks and prevent undefined behavior because you never get to the line of code that has the undefined behavior. But they don't change the semantic of the language in the sense that, you get something like, for example, a borrow checker, which changes how pointers work, or you get something like what you mentioned in your keynote, the erroneous values, where an uninitialized value, like reading that, you don't get undefined behavior anymore, right? It means something else to not initialize a value. So like changing language level semantics, that's not what contracts do. I think the way I see this is that there's a bunch of features that aim at providing more guarantees statically to the language, and I see contract as complementary to that. Everything that those features don't catch, contracts will then catch when your program is executing. That's kind of how I see contracts. They're complementary to those things. That's, again, my personal opinion, so I'm curious what other people think.
Okay. Gabby, please.
Okay. I guess I've been involved in the contract thing since around 2014, and other people have been doing that before me, but it's been about 10 years now. There has been several iterations. The one we have now, targeting C++26, is probably better than the previous iterations in some aspects, but it was a barely small improvement. I wouldn't say the current iteration of contract really address safety in any form. I have been hoping that it would, and as a matter of fact, about 2 years ago, early on when we rebooted the whole effort, I tried to push the group to actually take safety as a pillar principle that drives the language design decisions that we made. And at the time, I was kind of happy that the group was doing the right thing. We actually took a poll. Like, we have to prioritize safety above anything else. And, but vast majority, everyone's like, yeah, we'll do that. And then we didn't do that. Those of you who have been following the proposals probably know about the Tokyo meeting where I had to painfully stand in front of the committee and present it why Microsoft does not believe in the current iteration of contracts. It's only 2 pages explaining the fundamental reasons why. I would love to see progress made there. There's some work going on, but at a point in the language evolution where safety has become a fundamental focus, like I'm lying. We have U.S. federal government is looking at C+ people. The European Union is passing laws, poking at C++ people. We don't seem to be doing what we need to do. I agree that contracts don't change much the language. They should. And in my view, it's a pity that it's letting the opportunity goes to waste. It doesn't do really anything but undefined behavior, which is the main source of safety. Correctness also depends on having absence of undefined behavior, at least containing it. If we go from the principle that contracts are useful only if you write correct code, great. We haven't done anything, because the main reason why we have a contract is to contain the behavior of the program when we make errors. It is not just because some junior developer will write mistakes. Even the experts make mistakes. Experts make very obscure mistakes.
Yeah.
Right? It is just a matter of rate. Like, just write enough code, at some point you will make mistakes. And the ones written by experts are very, very expensive. So we cannot use the principle that correct contracts are useful only if you write correct code. We have to take the opposite principle, and we haven't done that. So I would love to say, yeah, C++ community, look for C++ citizen contract. We have something there for you to like, but right now, where I am looking at proposals, I cannot do that. I cannot say that.
Okay, thank you. Can I get one more before I go to the mic? Yeah.
Yeah, I do think Lisa wanted to say something about it, but if I could.
Okay, sounds good. I want all the contract experts
so
to jump in
again,
here.
I am very interested to see contracts succeed. I've implemented them. I love that. I spend time watching what that study group is doing. I'm not against contracts at all. But they aren't about safety. Safety is about guarantees. Every time you see Bjarne and Gabby talking about safety profiles, it's if you enable the goal is if you enable a profile and your program compiles, that it is free of certain classes of errors. You get it as a guarantee. When people talk about C++ is unsafe, and C is unsafe even more so, use Rust or C#, use a memory safe language instead, the delta is not contracts. None of those languages have contracts. None of them. Not the popular, the ones in mainstream use today. What they have is programming language guarantees that are enforced by the language, and what makes profiles the thing that we're talking about that's different from contracts is that they are like language rules. They are essentially language rules groups of language rules that you can opt into that provide guarantees. Think of it this way. By the way, nobody's defined what contracts are. So contracts is being able to write preconditions, postconditions, and assertions in your functions better than just the C assert. Ergo, they only help you when you write them. They only help you where you actually wrote them. By definition, they can't provide a whole program guarantee. It is a category error to talk about contracts in terms of type and memory safety. The perfect contract system can't do that. It's not what it's for. What are contracts for? For testing and for static analysis, static and dynamic testing, because static analysis tools can use it and runtime checks can use them. Therefore, testing for correctness. And yes, we might say, oh, but correctness, safety, that there's an overlap. There is some relationship, but let's not be confused.
Yes.
They're about testing,
Yes.
statically and dynamically, contracts. But we're here talking about safety. So the more we talk about contracts, the more I would argue we're off topic. But but it's a robust discussion and a good one to have, because a lot of people do see them something. By the way, and my biggest fear about contracts, and I'm bullish on them. I support the work the committee's doing. I want them to work through these problems. But they have failed in production in every major language that has tried to deploy them. C# has walked them back. Java, Python, Go, Rust, nobody has them in a standard way. And they're not necessary for type and memory safety.
Yeah.
And type and memory safety is what we should be trying to achieve in parity with other languages.
Indeed, it's because many people do conflate, and maybe there's another opinion. So I'm waiting for the speakers down there to come up with something. So let's have Lisa.
Well, as you can tell, there are many perspectives on contracts. You can come to my talk and find out some more. I'll just say my perspective is very unlike Gabby's, and I don't want to be here all night talking about how different they are.
Thank you.
My perspective is also rather different from Herb's. I think that if you're on a construction site, you put on a hard hat and your head is safer than it was before, even though your hard hat doesn't come with a guarantee that your head won't get crushed in. Contracts improve safety, but they do not perfect safety.
Did you want to? Yeah, and then we're going to go to the speaker.
Yeah. So Lisa, actually, I do agree with you that the notion of having a hard hat. My issue with and how your head is safer. My issue with the current specification of contract, it doesn't function as a hard hat. That's where my issue is.
No,
it is not that. So actually, unlike Herb, I actually do believe if you take Ada, for example, Ada 2012, it has contract and it has a subset Spark that actually relies heavily on contract and formal verification to provide better guarantees, right? Like you can do formal reasoning, as you mentioned earlier. You can use static analysis tools. It provides stuff, but it doesn't have the hard hat property. That's where my grip is.
Okay, I'm going to afford a chance for Lisa to rebut, but I wanted to give the chance for the speaker.
I'll let the discussion move on.
Thank you. Please introduce yourself, say your name, and then go ahead, please.
Okay, hi, my name is Devir. My question is not about contracts. I hope it's okay.
Absolutely. You can ask any other questions about safety security as well. Okay.
So recently, Sean Baxter published a paper about adding a borrow checker to C++ now.
Yeah.
It has quite a few language changes, like something that looks like epochs, and even I think a new STL with it. So I just wondered that if you had a chance to read it, and like, what do you think if we should add something like this, or?
I think we've all had a chance to analyze Sean Baxter's borrow checker-like C++ lifetime thing. So I want to get the opinion of the committee on that, starting with Andreas, please.
Yeah.
Louder, yeah.
So Sean's work is really impressive in that he proved that you can adapt the borrow checker model from Rust into C++ and what it takes to make that work. And if you have this, right, like the model that Rust presents is way better than any of the alternatives that have been proposed for C++, in my opinion at least. Like, this is a really strong model. It gives extremely strong guarantees and is able to do so very efficiently. What Sean's proof of concept also shows, and that is then the but, is what it costs you to pull this into the language. If you look at the paper, you will see it requires different types of references than we have in the standard today to express this notion of borrowing as it's used by Rust. It requires different kind of move semantics. It requires a destructive move, which I think is the better move, but it's not what we have in C++, right? And you need to introduce this. It requires basically an entirely new standard library, because the standard library that we have today just doesn't work with the borrow checker model. It requires lifetime annotations. It requires interior mutability. So there's lots of stuff that you need to add that are not in C++ today. And once you've added all of this, right, and you now want to write code, right? Like what you're writing in that model, I would claim, is no longer C++. And in particular, if you're facing the challenge how to interact with legacy code that was written in C++, and adopt this in this model of safety, it's going to be not straightforward. And that's the cost, right? And maybe that's a reasonable price to pay for the guarantees that it gives you, which are very strong. But you have to be aware that there's a price to pay.
Okay, someone else? Yeah, I know there's quite a bit of opinions, so I do want to hear them all, please.
Okay, yeah, but what you just said, I think the real challenge of C++ is that it is hard to live with history. We do not have the luxury of throwing away the billions of lines of code that have already been written. That if we evolve in the language, we have the duty to keep working. So the real challenge is, how do you take what exists today that we don't have the luxury of throwing away, and then add this additional guarantee that still feels like almost what was there yesterday, yet it is better. The proposal that's currently provided shows you how you bolt Rust onto C++. Now, understand that Rust takes some of the foundational ideas of C++, like Reis and move semantics, but make it like runners with very principle, like this is what is going to happen. I'm not going to let you do something slightly different, right? They've done a fantastic job there. But that is not how C++ really works. If you need a completely new standard library, which basically the proposal is suggesting, how do you deal with the existing code? You can't just throw them away, right? At that point, you better off either just go to Rust or a completely different language.
Someone else?
Okay.
Yeah.
So I've taken a look at it, and I do think it's very interesting. And yes, it is sort of, it is radically upsetting to the existing code bases. It's not a solution that fits in with the language as it is. It is, it would be a very big pill to swallow. But something I've been thinking about, and I don't know if this is going to pan out at all, is that maybe the problem comes from do the Rust model of borrow checking a little too literally. That is, maybe that there's a variation on that model that suits C++ better. And I have some vague ideas I'm not promising anything, but I'm thinking that it may be that, yeah, we might be able to do something like that. It just would be less rusty.
I like that. Anyone else?
Yeah, I mean, I agree with most of what has been said. I can't really add that much to it. But I think, Lisa, what you just said is interesting. There seems to be a spectrum. There seems to be two things, right? Do we really need 100% memory safety, or is it enough to have 99%? That's one question. And something like the borrow checker model says, no, we need to have 100%, right? And the question, I'm not convinced that this is what we need for C++, but if it is, then within that, there's also a spectrum, right? There is the Rust model, which, Sean Baxter, I agree, takes very literally. There is like the much simpler model of functional programming languages where you can only have values, basically. And there's stuff in between, right? There is the work that Timur and who else? I can't think of the name. Dave Abrahams, done on the Val language.
Is that the Val model?
I think called Hilo. That's this model of, mutable value semantics, which is kind of somewhere in between, like these two. And there's other kind of more exotic programming languages or experimental programming languages that are somewhere on that spectrum. So I think there is prior art to exploring slightly different models that still give you 100% memory safety. So maybe worth looking into that. And also, do we really need the 100% or is the 99% enough? I don't know the answer, but I think that's a worthwhile question to ask.
Okay, I'm going to give Gabi the last word, and I'm going to move to the next audience question.
Okay. Yeah, so when we talk about memory safety or type safety, it is not so much that there is absolutely no valid program in that language that will exhibit no memory safety bugs, right? What it is really about is, by default, the construct that the language gives you, how likely it is that you write codes that will just like take faults or that sort of thing. So Rust, by default, doesn't allow you to do certain things that would just be memory safe, right? But because it is also a systems programming language, you have to talk to the hardware. And talking to the hardware, funny things happen, right? So it's part of why you need this kind of thing like unsafe. Unsafe doesn't mean go and shoot yourself. It just means, I think here we have reached the limit of what we could check formally, and we'll let you write something. We'll still apply some rules, but you'll need some external ways of satisfying correctness of your program. And that is where, you might get into trouble. So it is really about the default. For C++, it is possible to write memory safe programs. Yep. The real question is, how does that scale? When you say it is possible, how scalable is that? By default, if you bring in new devs, how likely is it that the things you're telling them to do will just work out? That's what the real issue is.
Yep, thank you. The next speaker, please introduce yourself. And then...
Hi, my name is John Lakos. I work at Bloomberg. I'm very intimately involved with Sean Baxter's work. I originally got up to ask a question of Gabby and Herb. However, if I could have a minute to just say something about what was just discussed, because I have a lot of relevant information.
Yeah. Do you have a question?
Well, I wanted to give an opinion, if I could.
Okay.
So we've been working with Sean. Sean's ideas are amazing. However, they don't fit in with the current C++, ethos, because they want to change some defaults. However, there are many things that are short of what he's doing, such as trivial relocation and relocation that Bloomberg is working on. Mm-hmm. And these things are forerunners of what we're talking about. Think about move semantics. We added move semantics in 11. Relocation semantics is another semantic. Yes, it's true. Nothing will benefit from this unless we put it into the code. But we're looking forward. So if we're looking forward, future code, instead of moving to Rust, can simply incorporate this new syntax alongside the other so that people are not tempted to move to other memory-safe languages. I wanted to make one other point.
Yes.
What Sean is doing is absolutely distinct from contracts. Contracts cannot solve data races, cannot solve lifetime issues, period. And yet, contracts will do a heck of a lot more than anything that Sean is talking about today. Why? Why? Because if you put contracts in the standard library, and if you put contracts in the language the way Herb was talking about today in his keynote, such as integer overflow, for example, and you make those controllable in the same way that they're controllable with labels, and we're talking about C++ 29, you get all the code that was ever written now filtering through the standard library and the language under the control of the user. And this is extremely valuable to Bloomberg, which is why we're spending millions of dollars to make this happen. That's my whatever. Now, my question to Gabby. Gabby, yes. We're talking about testing. Contracts are a kind of testing. They're a runtime kind of testing. Yes, it's possible to make a mistake when you write a test case, like a unit test. So my point is, should we not write unit tests simply because the programmer could make a mistake and get it wrong? My belief is that, yes, contracts could be wrong. You could have some code that's right and write a bad contract. The single most important thing, in my opinion, is the redundancy, because we have a 90% solution, because human beings are 90% good, and we need a 99% answer, and contracts give us that. What is your reaction to that?
Oh, I am not at all. First, I agree that tests are useful. My argument is not against tests. You wouldn't find me there. My argument is that if, as language design, you take a principle that contract this thing that's supposed to like give you guardrails in your test and all of that, is useful only if you don't make a mistake. Then you have a big problem. So in my paper, about a year and a half ago, I actually showed an example where just making an innocuous error that most C++ programmers don't think about, which is integer overflow arithmetic in a test. The optimizer says, oh, I think that's undefined behavior. I'm just going to remove your test. That's what the optimizer is saying. Right? You and me agree that tests are useful. And the optimizer look at it and say, yeah, I'm going to remove it. That is what the problem is. Because now you have taken a contract, which is supposed to be this, usually if you don't have contract language level, they are C assert, like local to functions. You have put it at function declaration level. Now they are flying through translation unit. They have more power. It is on steroid. That is where my problem is. My problem is not that we have redundant. My problem is that as a language design principle, as we want to have this thing, I want contract. I really, really do. We also need to take the additional step to slightly change the language to say, hey, undefined behavior, we need to tame you a little bit. That's where my main concerns are.
Can I just agree?
And by the way, wait. I agree with you that if we put contract in standard library, it'll be fantastic. But last time I checked, everybody's against it.
Okay.
As a matter of fact, as part of the objections that Microsoft has, it's like, hey, you haven't tested this thing on the standard library. And like, oh yeah, we don't want to put it in the standard library.
Okay.
I just want to emphasize something. So first of all, I think I agree with everything John said and Gabby said and that everybody said about the circle work. So that's why I didn't take a turn going through the first time. But you said something really important. So John made a point that, first of all, Sean is a genius. And the work he's done with Circle and trying things out in experiments, this helps everybody. And as we learn, in its current state, applying Rust to C++ is a very disruptive, dissonant. There's an impedance mismatch there. But you gave some great examples, John, which is move semantics and trivial and relocatability, so kind of a destructive move that we're working on now. And this hits to the big difference. There's a big contrast because one of the things that we heard from all the panelists about the applying Rust borrow checking as is to C++, it's a kind of a foreign model. It's a different, there's an impedance mismatch. It's a different model. And so there's adoption is the issue and compatibility is the issue. There's breaking changes and possible bifurcations of the standard library, things like that. And that is exactly where move semantics shone and shines, and where the relocatability proposals currently, I think, are on the right track. There's two main proposals, and I think they're both heading in the right direction and converging, I think. And that is, how many of you in the audience, just a quick show of hands, had existing code before C++11, compiled the code without change on a C++11 compiler, and noticed it got a little faster because of move semantics? A few hands. Yeah, me too. And that's because that's a great compatibility story. Move semantics were designed so that the code, using the information already in the C++ code, the return by value, we just moved from that, from our values and temporaries. Yep. Great compatibility story, and relocatability is doing that again. And that is the opposite of an adoption step function. So adoptability is important, and making sure that we don't needlessly create an impedance mismatch is really important.
Yep. Thank you. I'm glad this topic was brought up on the Rust-like borrow checking and lifetime issue. It's kind of like the 800-pound gorilla in the room. People want to know, what do we feel about it? And is there another opinion there? No?
I'll just point out, people should notice too that even assuming that there were no impedance issues and we found a great way to adopt Rust borrow checking for C++. Remember that Rust, I like Rust. Rust, my team supports Rust at Microsoft, C++ and Rust. We love it. We're tooling it, investing in it. One of the things that Rust does better than any of the other memory safe languages, so it is safer than C# and Java when it comes to thread safety. Mm-hmm. But it is also less safe than C# and Java because it gets the thread safety by having the tree-based lifetimes. That's where the borrow checker comes in. Yeah. It's all tree-based lifetimes in the language, which means anytime that you want something else, like a doubly linked list or a graph, yes, there's the RC in the standard crate and so forth, but you need to use unsafe code. And the reality today is that because of that, you use unsafe code more often in Rust than in C# and Java. Yeah. Now, if you ask the question, which is more safe, Rust or C#, there's no answer, because C# is safer for some things. You use less unsafe code to have cyclic data structures. Yeah. Rust is safer for other things. It has thread safety guarantees. It's a trade-off. Yeah. Nobody has perfect safety. It's a shiny unicorn pony. Nobody has that. I would just say that Gabby and I have been talking about Rust for probably 3 or 4 years, because Rust is probably one of the first, made its biggest intrusion into functional safety through the automotive domain. They all been running towards Rust in a big way, but none of them, I think, have really put out any real production system as yet. I could be wrong. So go ahead, Gabby.
Yeah. So like Herb said, our team it like tools both C++ and Rust. My view is we want to make systems programmers productive, successful. Mm-hmm. Right. I think we shouldn't be language bigots. Mm-hmm. We should encourage pollination of ideas. Mm-hmm. Rust took Rye from C++. They put TIFF in it, and it is showing some results. Right. I think the C++ community should look at it and see what it can learn and take and evolve the language, mm-hmm. knowing that, because of history, it has to be C++. How do you bring the learning there back into and that is really, really difficult. Right. When you look at the interoperability, some of the things that came tangentially is if you have a safe, we're saying, how do you take the work that Sean has been doing and then plug it into what exists today? So we're talking about interoperability. One of the turning issues that the Rust community is dealing with today is interoperability between C++ and Rust. Right? So that is really, really, really difficult.
I know there's probably more opinions, but I need to move on. But I will close the subject by saying that I will channel Biana, where we've discussed this at length, and he has just one sentence, which is, it's not going to be C++ anymore. That was it. John, thank you very much for bringing that up. People can recycle and go back in line, but I do want to keep moving because now I've got a long queue. So please introduce yourself.
Hi, good evening. My name is Dov. I work in real-time embedded systems. And my question has to do with the thought process regarding the runtime price of adding safety. Obviously, compile time safety, I'm all for it, add as much as you want. But as I don't recall your name said, there's 99% safety, there's 100% safety in terms of runtime, in terms of code bloat, in terms of binary size. This all comes at a price. And harking back like 20 years, there was a whole discussion whether C++ and STL were even fit for embedded programming because nobody knew what was going on under the hood. As we add more and more features, more and more safety features, what are your thoughts on where the right trade-off would be?
Okay, I'll take that one because I haven't spoken in a while. I still believe in our maxima of leaving no room for a lower level language. Anything that unnecessarily takes up your runtime resources is something that has to be a thing you can work around. It can be on by default or something, but it has to be something that you can say, no, I need to be faster here.
Okay, next. Gabby, next, and then her.
Yeah. So, excellent question. If we take something as basic as memory safety, for example, it's a vector. I think behind me and Herb, I think, and almost everybody wants bound checking of vector bracket I, right? So if you compare bracketing a vector without bound checking, I was like, oh yeah, it doesn't have these extra instructions. So if you have constraints on fitting your executable on the small devices like these things, then you're concerned about how much of the redundant check is going to cost in binary size and possibly a runtime check which will drain on your battery, right? So that is a legitimate question. And if you go slightly further, and we're talking about type safety, so there has always been this rule in C and C++ that says you can't write something as an int and then try to read back as a string or as a double. That's type punning. And if you do, then the compiler is allowed to go and completely rewrite or completely reformat your hard drive. So when there are times where you need to reinterpret a bit to mean something else because you deal with the hardware. Hardware is funny. Then you need to spend the extra cycle or stores to actually get that right. So it's always a balance between correctness, like go fast, do correctly and going fast and using resources very, very carefully. So if you look at profiles, for example, memory safety profiles, it has bound checking there, right? So it will say all indexable containers or views will be bound checked. And if you have additional proof that those additional checks are redundant, then you need to communicate that in some ways to the compiler or to have the code analysis tools and the optimizer work together to reduce that. So I guess what I'm saying is we will need additional advancements in the tools. Some of it already exists, but we need more collaborations. Like the backends need to spot those redundant checks and take them away.
Okay.
Herb? I agree with those things. Can I try to put it to the nutshell that the way I see it is if you have to have runtime checks, having them be on by default, being a way to opt in to check my subscripts and dereferences by default is great, and it's still C++, and it still obeys the zero overhead principle that you don't pay for what you don't use if you can opt out in a hot loop. Because most of your subscript operations will never be in a hot loop, or they may not contribute to code size enormously. Otherwise, you shouldn't enable that profile if it does. But you can have them all on by default, but then you find in this loop, it costs because the compiler isn't smart enough to hoist the bounds check, put in unchecked subscript there. We have to have a way to opt out, but I would love to see that to be greppable in source code so that if later there is a bug, we can go and look at those places first.
Yep. So this harkens back to your slide this morning about opt-out versus watch-out.
Take another crack at this one.
I'm gonna. So Andreas, did you? And then we're gonna go back. Yeah.
Yeah. So one thing that I think is important we keep in mind is that, like, people that use C++ today, right? They use it because the unique selling point of C++ is that you get the maximum of performance, right? And you know that the price for that is the various foot guns that are there, that it's hard to use. And now, of course, the risk that you have if you say you change focus and you make it safer and you introduce a bunch of runtime checks, is that you weaken that original proposition of the language. I don't think, like, with the way that the discussions are currently going, that we are at risk of doing this. Like, the committee seems to be very conservative about giving up performance guarantees. But I can see why, like, certain people for whom safety is just not a concern might have that worry. And yeah, I think it's important to keep that in mind and to not lose that original audience for the language.
Okay, I want to give Lisa the last word. Yeah.
Well, in a broader sense, and getting back to what Gabby was saying, if you know that your bounds check would never fail, that is, that your array index in a certain place is always in bounds, and you know this for a reason. It's not just, blind faith. It's you have reasoning that shows that this is true. Really, what's missing is you haven't, if you can explain your reasons to the compiler, and the compiler will also see that it's true, then it can leave the bounds checks out. It's, this is just a general principle that being able to express your reasons gets you out of having to check things at runtime.
Can I just add real quick? Range 4 is a great example. By construction, it visits every element in the range. So by construction, the compiler knows it only needs to do the bounds check once.
Thank you. Thank you. Next question, please. Introduce yourself, please.
Hi, my name is Jordan Montgomery. I work in safety critical embedded code, and I've seen a lot of discussion here, especially from Herb, that we may only be able to achieve 99%. And my question is, what does it mean for program safety and correctness if we can only achieve 99%? When I go and I look at something like MISRA, it doesn't say as long as 99% of your undefined behavior is gone. It says all of it has to be gone.
Good question. Thank you.
Yeah, so,
okay, wait. So there's something that we have to talk about here, and you're opening the can here, which is that, is it possible or meaningful to achieve 100% safety? Is it even doable? Let's go start with her then.
First of all, what does that mean? So normally when people ask for that, they're looking for formally provable type safety guarantees. No commercial language has that, including all the MSLs people are asking us to use instead. And it is not necessary to have it because the other memory safe languages are doing just fine, even though you have to remember, for initialization safety in C# and Java, don't call a virtual function in a constructor because you'll see an uninitialized derived object. Like you can violate, you just have to know that. And that is plenty good. We consider the memory safe languages. What we should be looking for is parity with that. So it is neither necessary to have 100%, nor is it sufficient because memory safety is not the be-all and end-all. It's only 7 of the top 23 MISRA common weakness categories. from 2023. So yes, we should do it, but there's like 18 others that we should be looking at, other categories where we're not leaking secrets or doing SQL injection, or we're sanitizing inputs and all those other things. So there's been this focus on memory safety because it's the thing that other languages are good at, but it is not a be all and end all. And perfection is not the thing. Parity is what we want, not perfection. That's my argument. And the other, then finally, because that last few percent isn't worth the cost. That's why they don't do it either, because it's not worth the cost of getting, because you get diminishing returns, and then you get more incompatibilities, such as having to install a borrow checker or other things like that. I didn't mean to pick on the borrow checker. It's just an example that we were just talking about.
Okay, so I'm going to continue with the speaker queue. Was it you or was it? Yeah, okay, go ahead. And then I'm going to go to you, sorry. Yeah.
Yeah, I agree with everything that Herb just said. And I'll add further that it really depends on the point of view that you have. If you're a security engineer, security researcher, then it's like, oh, I need to secure this thing 100%. You're going to have defense in depth and everything. Like, people who are deploying memory safe languages today, they're also adding adverse sanitizer, right? So it's really about the point of view. If you're doing systems programming, at some point you have to talk to the hardware. And the hardware's notion of things is very often very different from the models that we have when we design a language. At that point, then you need some construct to say, trust me, I know what I'm doing, and you have no clue. It is that weak link where someone can go and drive a truck through.
Thank you. I'm going to call on Timur and then Andreas. Go ahead.
So I think that even if you would have 100% all the safeties like type safety, memory safety, initialization safety, everything that's been mentioned, that wouldn't actually give you functional safety, and it wouldn't give you correctness either. And so like, for example, you could have a language where you can never have, uninitialized memory, you can never have any of those problems, but you could just make a mistake in your program, and then your car will crash into another car because you didn't account for like accumulating floating point error or something like this. And even the safest language in the world would not save you from that. So I think that's something where like correctness features like contracts, for example, might help you. But it's not something to do with memory safety or those things. So you could have that 100% even, and you would still not have functional safety. And the flip side of that is that, well, not the flip side, but one aspect of this is, I like this example of you can take a completely memory safe language and you can write a C interpreter in it. So that's possible, right? So like we need to be precise what we talk about when we say something's safe. And functional safety is something, I'm sure Andreas knows a lot more about this because he actually works in this domain. I don't. But functional safety is very different from having all of the language safeties. And correctness is yet something else. And you kind of want to have all of them.
Thank you. So because you specifically mentioned MISRA, I'm going to ask Andreas to say something.
Yeah. So I don't disagree with what was said before. But if I put my safety hat on, right, and I have the choice, like, other leaving factors aside, like whether I can get a certified tool chain and stuff like that. If I have the choice between writing a safety critical system in a language like C++ or in a language like Rust that can get the job done, meet like the performance requirements, but give me that safety guarantees on top, today I would choose Rust. Like in a safety critical environment, I think there's no reason not to choose Rust in such a situation. There is like external factors that make that choice a bit more complicated right now. But the truth is that like for those use cases, C++ doesn't have the best answer right now. Like and Rust has a much more compelling story in my opinion. And that's yeah, that's a bitter truth, right? And what does that mean for us at C++? Does that mean that we're just going to lose like these like highly safety critical systems? Now we also have this pressure with the changing regulation. Does that mean that like more use cases that are not currently in that same space as the safety critical will move closer there? How much will we lose? And that's a tough question. And I don't see us currently having a good answer like for those people that are already in this place where they can benefit greatly from these increased safety features for keeping them.
Before I hand it to next person, I am going to ask you the question he had about MISRA never saying anything about how much percentages it covered. Do you have an opinion on that?
Yeah. If we could get 100% with MISRA, we would take it. It's just in many cases too difficult to get. Yeah, like with MISRA, we always have a trade-off between like the increase in safety that we can achieve and the practicality of the rule, right? The rule still needs to be checkable. We prefer it to be checkable cheap so that you don't have to do like global analysis and potentially undecidable checks. So we try to hit a sweet spot there, right? Like keeping you away from most of the dangerous stuff, but still make it like reasonably checkable. And yeah, like that's like all engineering, right? There's a trade-off there, and we just try to hit a good sweet spot.
Thank you. Sorry for putting you on the spot. Herb or Lisa? Yeah. Lisa first, okay.
I would like to reply to that, but there are too many things to reply to. I will reply to what Herb said. I disagree with him. Given a choice between perfection and parity, I'll take perfection. Yes, I do know which one is closer at hand, though. Parity might be easier to get to. I am an optimist, though. I do think that, I come from the world of mathematics. We do proofs. We are very, very confident in the things that we prove. And there is no reason that programming can't be the same way. We're not good at expressing proofs about programming. It's much, much, much harder than it should be. We reason about programs all the time. We're very good at that, and we have terrible ways of writing down those proofs. And it's honestly because we tried to take those things from the mathematicians, and they're doing it wrong, or doing it wrong for programmers. But I think we can really move in that direction given time.
Next is Herb. Yeah, sorry, Herb. Yeah.
So, Andreas, you have expertise. I do not. I do not know your domain. I have, however, lately been talking to a lot of people in your domain. Let me try to channel what they said, because what I heard from them was the opposite of what you just said. And please correct me. I'm not trying to argue. I'm trying to understand.
No, I want you to argue.
No, you're a Canadian. Too. So great. Now you're going to make me lose my train. Okay, here we go. So the following is not a ding against Rust at all. I like it. It's a great language. None of us should be language bigots. It's got great guarantees. I agree with that part. Thread safety guarantees that other languages still aspire to. That's great. A language does not exist in a vacuum. Ecosystem matters. Tools matter. When you talk about automotive certifications, I was very recently in a meeting with an expert who's got 30 years of experience with automotive requirements and real-time systems, who said to a group of people who were big on pushing everything to Rust, and said, look, the reality today is Rust is a great language, But none of those legal certifications, none of the government requirements that exist today for you to ship automotive software support Rust. They are all verified tool chains, and they cite MISRA and a whole ecosystem of standards and protocols and legal requirements that exist for C++ today and for C, but not for Rust. And I think this is a direct quote from what he said. He said, this is not against Rust because Rust can get there. It's just going to take another decade of work or so, or 5 years, or depends how much we invest to get there. But today, for those systems, Rust is the risky option, and C and C++ are the safe option. They are the well-trodden path that has the ecosystem of required regulatory certifications that Rust doesn't yet have. Doesn't mean it won't have it. We should build that for Rust too. But today, it struck me that he said C and C++ are the safe path. Rust is the risky path, at least as a point in time.
So I want to give Andreas a chance to rebut, and part of it is because I caught a sentence he says, I use Rust, but there are complications.
Yeah.
And I think this is what you're going to expand
exactly.
on.
So that's,
I noticed that. I wondered if that's what you were.
Yes, let's hear those complications.
That's what I meant by there are external factors that complicate the.
Like what?
decision.
What are they? What are those complications?
An obvious problem is that you need a tool qualification usually when you deploy in safety critical systems. Yeah. There's people working on that, like Ferrocene in Germany. Part of that is that you need a formal spec of the language, which Ferrocene has provided. It's not a complete spec. For example, it does not include the borrow checker yet. Another thing that is a big part is that those functional safety standards usually require you to have guidelines like MISRA. Yeah. And Rust does not have that yet. There are activities to get that eventually. One thing that is particularly difficult there is that we'll probably have to talk about how to deal with unsafe segments in Rust, which are very challenging to write correctly, and it's not very well documented. That knowledge is still not widely available in Rust. So there are those factors that need to be resolved. But like you said, right, that's probably just a matter of time.
Exactly. C++ has a 30-year unfair advantage. They've just been around longer, right? Yeah. So again, this is not a thing against Rust. It will get there too. But today in 2024, it was interesting for me to hear that experts say that, well, right now it's the risky choice. Yeah. And of course, this will change. We'll have a different discussion 10 years from now. Yeah,
in particular, in safety critical, it's always the evil that you know is always better than the one that you don't know, right? We know what to watch out for in C++ and how to mitigate its problems.
I like where this is ending, but I need to move on. Yeah. So thank you for that.
Can I just emphasize, the key thing, though, isn't about Rust this, C++ that, and regulatory guidelines. To me, the important key part is no language exists in a vacuum. A language by itself is never a solution. Right. Always consider the ecosystem and all the externalities, too.
Yeah. Thank you. And I'm going to have something else to say about that later on, but not right now. We've got 2 more people, 20 minutes. So, 3 more people. Come. It's okay. Go ahead. Fire your first question. Introduce yourself first, please.
Hi, I'm Tyler Weaver. I will admit to being a little bit of a villain, but follow up on what you're saying. I've been writing C++ for only a single decade, and recently have been working full-time in Rust. And I will say that while the safety guarantees of Rust are great, we care a lot about writing correct code. I work in a domain where we don't need legal documents, but if our stuff doesn't work, we might bring the end of the world. So we care about correctness a lot. Mm-hmm. And Rust helps us get there a lot easier. But the real thing that Rust is eating C++'s lunch in is tooling. Rust has a 30-year time deficit against C++, but it's killing it in packaging. And if C++ doesn't figure out packaging soon, I fear that, that will be the end.
Okay, so what about that packaging? Gabby.
Oh, yeah. So great point. The C++ is in this weird position that it is that there is no packaging. Like you have at least 4 or 5 popular packaging systems. And Rust has one by default, the one they're developing a language with, and it comes with that. So it's just not that C++ hasn't figured out packaging. It is that you have a lot of opinions about how it should be done. I'm not sure if it makes sense. Yeah. So, and part of that is a reflection of the various domains where C++ is used. It's not just that C++ developers are masochists or lazy. It is just that the different domains of applications. Depending who you talk to, it is the most important things that C++ supports. And quite often they have very incompatible demands. And that is why you have these, I would say, fragmentation of packaging systems.
Can I comment on this?
Go ahead. And then Andreas, go ahead.
So I don't know anybody who doesn't want to solve packaging in C++. At some point, not too long ago, I remember I asked this question on social media because I was looking at one of the really popular package managers and I thought it was working really, really well. And so I was like, what's missing there? Like all the functionality you need in a good package manager that seems to be there. And I got a bunch of replies, but I think the most common one was, but it doesn't come out of the box. And it's kind of a weird catch-22 at that point. It's like, we know how to do that, but because it's not standard, it doesn't come with the compiler the way it does in Rust. Like people don't adopt it, so the libraries are not on it. So and I think that's the problem. That's like this weird catch-22. It's not that we don't know how to solve the problem on a technical level.
Andreas?
Yeah. So disclaimer: I have CMake Stockholm syndrome. I think it's actually a great tool, and it gets a bad rap undeservedly. I think Rust is really good if you're looking at new libraries, right, that were written in Rust for the cargo ecosystem. If I'm only looking at C++ libraries that were written for a modern CMake ecosystem, I would claim that integrating them is not that much harder than with cargo. It's still not as nice, but if you use, especially if you use Conan, if it's a well-behaved CMake library, it's okay, right? I can live with that. Where it gets hard is if you have legacy libraries, right? If you have C libraries, if you have libraries that have weird build chains that you want to pull in. But if you have those libraries, pulling them into Rust is just as hard. I think it's an unfair comparison, right? Because if you only look at the newly written libraries in Rust, yeah, of course they play nice, right? But you can't say the same about the newer libraries written in C++.
Any last words before we move on? Okay, let's keep going then. Thank you for very much. Next, please.
Okay, my name is Herman. Mm-hmm. I wrote my first Hello World in '92 or so, but born in C++.
Thank you.
I've been in airspace traffic management for 2 decades. So safety is very important there. Every time there's human life at stake or injuries, it has to be considered and the risks have to be looked at. There was a session this morning from Ben Sachs about this little word volatile. And to my surprise, he said there were 2 guys doing quite some investigations, and they found out that some compilers were really, in some cases, generating wrong code. And that can be a real safety problem, I think. So we're always until now focusing on the language itself, but the compilers, they have to do a lot. They have to compile fast and generate code which is fast, optimize. What can we do with compilers that have to follow the new C++ 26, 29 and make sure that they are safe too in what they generate?
Okay. Compilers, optimizers, what do they do together to safety?
That's a tough one.
Mm-hmm.
So more seriously though,
there has been, and I think there's some effort to try to bring more formal verification to safety. So if you look at ComCert, which is this compiler written in the CockProof assistant by Xavier Leroy, it is a C compiler whose its actions are directly related to the specification, and each phase is proven to be correct, preserving the semantics assigned by the standard, so that if there is a bug, either it is a bug in the logic or most likely a bug in the standard itself. But to my knowledge, he has the first and only C compiler, not my version or his version, but the C compiler that's at scale, used in avionics by Airbus and others. They still have to go through all the certification because nobody wants to tell passengers, welcome on this new Airbus system. All the systems are correct, but they have not been tested yet. You don't really want to fly that, right? Even if they're correct. But that is the only industrial effort that I know of. I hope there are more efforts like that to come in the future.
Okay. Anyone else? All right. We want to keep moving on. Thank you for that question. Next, please.
Hey, my name is Alon Wolf. I'm wondering, in Rust, there is safe and unsafe. So you can either have all of the constraints of the borrow checker or none of them, which is not very flexible. I'm wondering, what is your opinion of being able to express costume compile time constraints in a way that the compiler can validate, and being able to apply, being able to choose which ones to apply for each context?
Herb.
Is that profiles? I think what you just described is what the profiles proposal tries to do.
Yes, I thought you.
Yeah, but being able to create costume constraints, so you can
Yes, and the profiles
exactly
proposal.
What profiles are about.
Yes, they want to do type in memory, but they say, hey, and you should be able to write your own profile and have it be an extensible framework.
And one of the work that remains to be done is working with SG15, the tooling study group, to specify how people are able to communicate their own custom-made profiles to compilers and so forth. So the C++ profiles are really from the perspective of gradual adoption, increasing severity or strictness and so forth, as opposed to just binary, because we don't believe that safety is just 0-1.
Yeah. I do want to say that I think that that's even a little unfair to Rust, because a single program very often mixes both safe and unsafe code. Having the level of granularity be the same as the granularity of functions it's a choice. I'm not certain it's a terrible choice. It just makes you sometimes write two functions where you would otherwise write one. But it's really a question of how much work do you have to do to break it into here is where I'm checking X and here is where I am not checking X.
Okay. Any other feedbacks? My queue keeps growing, so I have to keep going. Thank you for that question. I actually have some questions about profiles, but I don't think I'm going to get to ask them. So next, please.
Yeah, hi, I'm Dave Steffen, and it may be a little late to open this can of worms, so if you want to...
Never too late.
So we were talking earlier, we're going to add things to the language to make it safer or use this other language because it's safe, and then it was brought up that you can't use Rust in some places because you haven't certified the tool chain. So my question is, at what point do we get serious about the other end of that problem and we start certifying our developers? Because I work at the same place these guys do, and we are growing and we're trying to hire, but where do I go find people that I know for a fact are going to know what they're doing? How do we tackle that?
Yeah, it's an excellent point. When I was in academia, with Biane, we used to make the point that just about any other engineering domain, you actually have certification. Programming just seems to be the only one where anybody with keyboard and email domain is a programmer, a software engineer.
as the regulations, laws are being pushed, I suspect the end result will be that we will be seeing also push for certification for software developers. Like if a big software company now has the liability of if something bad happened with your software, you're on the hook for it. I think they'll probably turn around and say, is that guy we're hiring certified? Just like when you have doctors, if you go see them, they buy insurance because sometimes something can go wrong. So with the evolving regulatory domains, these aspects will become more prominent.
Okay, Herb, you have...
That's almost everything I was going to say. I'll just add we're on the way to, at some point, I don't know if it's going to be in 5 years or in 50 years. Like it may be when we're all gone, but we are in the process of going toward regulation and being real engineers. But remember, we are a young industry. We didn't exist 60, 70 years ago. But we are a super young industry, so we're still at the tradespeople stage, and we're learning some engineering disciplines, but it's with less of the formal. Here are the centuries of experience in civil engineering, and all the things to do and not to do, and that has been accumulated in other domains that are older. And besides, it's not just the age; it's that we're still inventing, like. So how many AI certified people are there? How many were there 10 years ago? There was a negative number 10 years ago, right? So,
for that matter, can you make AI safe?
Oh, let's not go.
Let's not go there. Thank you very much. Next person, please. 5 more minutes left.
This is a question spoken partly out of ignorance. I learned about the profiles proposal from Herb's talk this morning, so I have not had a chance to even begin to read it. But the question is, will it be possible? Until recently worked for a company whose main product was a library, and there were some problems we had with guarantees made by third parties, which meant we couldn't incorporate them. Behaviors that we couldn't incorporate, so like things like automatic termination on air that was unacceptable for some of the things we had to deploy into. So I understand completely like where the profiles is coming from. We had a de facto rule in my group that I insisted on enforcing that we not use undefined behavior anywhere because we had compile in multiple different platforms. Will the profiles, so this is the question specifically, will the profiles thing allow us to accelerate all undefined behavior that's detected in the code into a compiler error so that we never get past the issue of even needing to worry about what it might mean by the fact that it'll not compile to anything that we have to worry about? Is that a potential profile I could write? No undefined behavior, full stop. Give me a compiler error instead.
Okay, so I'm going to aim at Gabby.
Yes.
And then Herb sounds like wants to say.
So a compiler that, let's say, has an option of saying, I'm going to compile this program without exporting undefined behavior in a form, and if I detect, I'm going to generate runtime code if I think something is going to be undefined behavior. We have been having some of those already in practice, like if you say UBSAN, for example, that's that, right? You have a compiler option that allows you to generate more additional runtime instrumentation. So you can imagine that there is a profile, UBSAN profile that you activate when you compile your code. To turn that back to the community, I think it'll take like collective effort, cultural change to accept that we collectively wanted to control undefined behavior. I have been chair of the SG12 for 10 years, where we were supposed to eradicate undefined behavior. Eventually, we had to admit we can't because the community is fragmented. The problem is not technical, it is cultural.
Okay. So Gabby, let me riff off that though, because with context per code, no language you beat, basically.
Correct.
Right? So we're already there.
Yes.
Like the factorial example, factorial 13, store the result in an int. If it's running, I'm going to say what you're about to say. Runs at compile time, great, we can eliminate that. Other undefined behaviors, however, we have to change the code gen because that same factorial function, written factorial of a runtime value, You can't check at compile time. What you do at compile time, though, is you can write a less efficient checked operation. And that's the kind of thing I could see being in a profile, because now we want checking to be opt-in and opt-out. And that's where that kind of, that category of UB that requires checks would be appropriate for a profile.
Yeah, agree. And to add to that, so it's a good example, context for example. People were willing to accept that because they were seeing the benefit of context, where they could do this sort of stuff they couldn't do before. If only we can, like, that's why I say it's a cultural problem. If we can only bring the community into viewing the value of the absence of UB and not complain about someone taking away their UB, then we will get what you just described as an example.
And speaking of the value of constexpert, there's Mr. Constexpert with the hat.
Okay, I need to keep going. Last words, please, before I with some closing questions.
Oh, okay, I actually wanted to ask a question to her, because I don't think it's that easy to say, oh, we can get rid of undefined behavior in constexpert. Like, if I think, for example, about data races, how would I diagnose this at runtime?
Wait, but data races in constexpert code?
No, like in non-constexpert code. Like if I want to get rid of all UB, right? Like diagnosing data races.
Yeah, and data races is the one that all the memory safe languages except for Rust punt on.
Thank you.
It's like, it is Mr. Programmer, Ms. Programmer, it is your responsibility not to write a data race.
Okay, thank you.
I
need to move. I need to close. Thank you. I want to close by asking each of you to give your opinion. Next year, we're going to be back here again, I hope. What would you hope to have accomplished by next year at this time that you can tell people? I know it's going to be a wish or prediction. Start with Andreas, then I'm going to move through each person.
You already know one?
So for me, that would be more development on profile, making it real, like people taking their compilers and doing it, and not just technical aspects of it, but also culturally, because we need that.
Thank you. Next.
Okay.
Let's start with you, Timur. I think you jumped in. Yeah, go ahead. Go ahead, Timur.
Sorry, I didn't know there was an order.
I know. I'm the one who's watching it. Yeah.
So, of course, I would like to see contracts adopted in the CSS 26. That I think is my personal number one thing, but I would also like to see more things like what we did, for example, with the uninitialized values, where we flip the default. Now you have to like opt into having an uninitialized value, so you can still get the raw performance, but you have to actually put an attribute on it. Okay. I would like to see more stuff like this, where we kind of chip away at things where we know we understand the trade-off of flipping the default and making something not UB, kind of not on a level of let's introduce a borrow checker, but on a level of let's take this little feature and just flip the default so it's not UB by default. I would like to see more features like that on the standard. I think that would help us a lot.
Lisa.
Okay, you did ask for personal accomplishments.
It's a personal.
So I'm going to be focusing on getting contracts adopted.
Thank you. Herb or Andreas? Who wants to go first?
The same as has been said. I'm interested in all those things.
Okay, Andreas.
I hope that we can get MISRA C++20 ready.
Thank you. Herb?
Oh, I just answered the same as all those things.
Okay. Well, thank you very much. Thank you very much for the great discussion. I'm very grateful for you guys to be here on this panel. There are many questions that I still want to ask, but we're out of time. We also have next year that I'm hoping that we will come back and be able to talk more about the development. Every year, there's going to be more and more developments as C++ pushes into safety, security. I wish I had everybody who is an expert on this group. I wanted to talk about, contracts and its implementation. Unfortunately, Nina's not feeling great, so I couldn't get that up there and talk about it. But hey, we're going to do the best we can every year. There's just more than enough for us to discuss here. So with that, I would like to ask you to give the panelists a hand.